learned about 6.3, the row reduced echelon form, where we can use our matrices math to solve equations. Then we just did 6.4, which we did 3 computations, addition, subtraction, multiplication. What computation did we not do? Division, okay? So in the matrix world, there's really no such thing as division, okay? So instead of dividing, they multiply by its inverse. And the whole idea is, guys, do you agree that dividing by 5 is the same thing as multiplying by 1/5? Yeah. Right? The 5's on the bottom, right? Or dividing by 1/2 is the same thing as multiplying by 2. So division is the same thing as multiplying by inverses. And so that's kind of how matrix math works. They don't actually ever divide by a matrix. They multiply by its inverse. So that's what this is all about in 6.5. It says that an identity matrix is a square. So it doesn't matter, it could be 2 by 2, 4 by 4, 8 by 8, I don't care, but it's a square matrix. And so look at, these are 2 examples, and we can use these matrices to find inverses and vice versa, okay? We are not going to do it by hand. We don't have to do it by hand, but I just want to kind of introduce that. So the whole idea is, so if I have a matrix that's square, for example, this guy up here, he's a square matrix, what's his inverse? He has an inverse because it's a square matrix. Nope. 4? You don't know. Like, it's a whole matrix that is, meaning, what do I multiply him by to get the identity matrix of? It's a lot more complicated than that. So again, it's this whole idea of division. Like, you have this unknown matrix, its inverse. So you technically want to divide both sides by him, but you can't divide both sides by him. So what are we introduced to? The inverse of A. So see this little notation down here? This just means the inverse of A. So A inverse is another way of thinking I'm dividing by A, okay? So it's pretty complicated. So again, we're going to do it on our calculator, but please note that A must be a square matrix, okay? So I could give you a quick true-false question on the test and say, does this matrix have an inverse? For example, does this matrix have an inverse? No. You'd say no, because it's not a square matrix. Does this have an inverse? Maybe, because it's a square. So what we're going to do, we already have C in our calculator, okay?
How is it not, isn't that the 3 by 3?
That's a 3 by, oh, it is 3 by 3, sorry. I was thinking that was shorter. I didn't write it very square. So you're correct. This guy doesn't. This is a 3 by 2.
Like the same
they match. Yep, sorry. For some reason I saw a squatty, so I was thinking 2 by 3, but you're right. That's a 3 by 3. So he would have an inverse, he would have an inverse. He would not, because he's a 3 by 2. He's not square. All right, so how do we do this in our calculator? You would type your matrix in there. We already have C in there, so let's pull C up. So second, oops, you got to turn this back on. Second matrix C, okay? And then see what our matrix button is connected with? The little -1. So if you type that, he gives you the inverse. Hit enter. You're like, oh my goodness, those are some really ugly decimals. How do I do that? Guess what still works? Math_frac. So math_frac still works on our matrices. So you hit math fraction. There he is, okay? So our inverse matrix is 1/7, 3/7, -1/14, and 2/7. And what does this mean? It means if we took our original matrix C and multiplied by this matrix, it would equal 1. Okay? So you can even do that. Like, I wonder if we can do answer. So I'm going to do matrix, I'm going to see, this is the first time I've ever tried this. I'm going to do matrix C times second answer. And you get the identity matrix. Okay, so that's what it's about. And again, we don't get into it, but why would inverses come in handy? Because it's another way to solve equations. So if you didn't want to do row reduced echelon form, another way would be have a matrix and times a matrix equals another matrix, and you would technically divide, right? And so it's all this kind of same thing you would do with equations, but instead of dividing by a matrix, you just multiply by its inverse, and it's the same thing. Okay? That's 6.5. Are there any questions on 6.5? Yep, just know the -1 up top means the inverse of a matrix, and if you take a matrix times its inverse, you get the identity matrix where it's ones down the diagonal.
Now
6.6, the last one in chapter 6. Determinants in Cramer's rule. We don't have to cover Cramer's rule in this class, so I'm not going to. So we're just going to talk about determinants. And what determinants are, again, they're only on square matrices, okay? So the determinant of a 2 by 2 is very easy to find. A determinant of anything bigger than a 2 by 2 matrix is complicated to find, and we won't get into it. We'll let our calculator do it. But what I want to point out in the determinant is determinants, again, are like 6.5. It can be a different way of solving equations. So all these things that you're learning are just different ways to solve systems of equations. What I want to point out to you is notice that when you find the determinant of a matrix, the determinant symbol is kind of like absolute value symbols, okay? So the absolute value symbols equals determinant. Notice the symbols, right? So if they just said find this and it was a matrix in these absolute value symbols without saying it in words, they're asking you to find the determinant, okay? Of a 2 by 2, it's very, very easy. It's kind of just like the cross product, okay? So notice the determinant is just found by taking the first diagonal, A times D, minus the second diagonal, B times C. Do you guys see that? So they're just multiplying these two guys first and then subtracting these. So again, kind of like the addition and subtraction of matrices, sometimes it's easier just to do it by hand than worry about inputting this matrix into our calculator and finding the determinant. So since this is a little easy guy, we'll just do it by hand. So this says it in words and with the symbol. It says find the determinant, but notice it has the symbol for determinant as well. So we're going to do 4 times 2 first. 4 times 2 minus negative 6. 1 times negative 6. So we really get 8 plus 6 or 14. So the determinant's 14. You're like, I don't know if I trust my math and want to double check it. Throw this original matrix in your calculator, okay? So let's do that real quick so I can show you how to do that. We'll do second matrix. I'm done with these A, B's, and C's from before, so I'll just edit A. What size matrix is this? 2 by 2. Go ahead and type in its entries 4, negative 6, 1, 2. Does that look okay? Get out of there. And then it's just kind of like the row reduce where we're going to go to second matrix again, all right? But we're going to scroll over to math, and I think it's the very first thing that you can choose. So if you scroll over to math, see how you have DET to choose from? Yep. So second matrix, then scroll over to math.
Yeah.
See, DET is the very first thing. That's number 1. Yeah. Okay. So and it's like, what do you want me to find the determinant of? Matrix A. So let's throw matrix A in there. You get 14. Okay. So again, if it's a 2 by 2, I would just do it by hand because that took a lot longer than us just doing it by hand. Now, finding the determinant of a 3 by 3 is a way more complicated, something that we don't have to get into. So we are just going to want to make sure we can put this in our calculator and find the determinant. Okay? So I'm going to go to my matrix, and I'm going to go edit. I'm done with everything, so I'm going to edit A again. What size matrix is that? 3 by 3. And I'm going to type in all the parts, negative 8, 0, 6, 4, negative 6, 7. Negative 1, negative 3, 5. Okay? You get out of there, so you hit second mode, you get to your main screen, you can clear it off, do whatever you need to. And what do we want to find? We want to find the determinant. Again, it says it, but the symbols mean find the determinant. So you do second matrix, go to math, determinant's the number 1 thing. I edited it into matrix A, so I'm going to make sure it finds the determinant of A. So the determinant's always a single value, so kind of keep that in mind as well, because you're so used to like doing the math with matrices and another matrix pops out. This is the one thing where it is just a single value. So we did this on by calculator, right? You get negative 36, okay? So determinants, we don't need Cramer's rule. Determinants are a single value or number. So keep that in mind to know that you've done it correctly. And again, we're not going to get into it, but using determinants, there's another way to solve equation using determinants, and you can go about that. In a nutshell, though, I would do 6.3. We know how to do it. Our calculator can do it. Just throw your matrix into your calculator and do row reduced echelon form. That's really the only solving you need to know how to do. But determinants and inverse of matrices are 2 other ways that we could solve equations as well.